Well, let's get started with 2.2, which is titled Polynomial Functions of Higher Degree. Tell me, what functions have we learned about so far? Like what degree were those functions? What degree?
We did quadratic and
Second and third.
second power.
Sure did. Sure did. Second one was the quadratic function, and the third degree, which is the cubic function. Very good. So the highest we've gone so far is degree 3. But today you're going to learn how functions look when they are higher than that. Higher degree. Degree 4, degree 5, and so on and so on. All right, so objectives, we're going to identify polynomial functions, recognize characteristics of graphs of polynomials, determine end behavior, use factoring to find zeros of polynomials, identify zeros in their multiplicities, understand relationship between degree and turning points, and here we go. A polynomial function is a function of the form f of x equals all of this. Now, I know that looks like a lot of stuff, but it's really not. It says where n is a non-negative integer and each a sub I is a real number. So all of these a's are basically coefficients. And that last a would be called a what? It's not attached to a variable. What would it be called? That last a sub 0.
Is it a constant?
Sure is. It's a constant. All right. Normally, you will see a constant at the very end. It's not always, but normally it's at the end. If it's not in descending order, then it may be somewhere else. But normally, when it is in descending order, the constant is at the end. The polynomial function has a leading coefficient a sub n. Well, that makes sense because it's right here in the very front. Sometimes it's in the front, sometimes it's not. You have to be careful where the leading coefficient is, and degree n. So in this section today, we're going to refer to n as the degree. All right, examples. Find the leading coefficient and degree of each polynomial function. So have a few examples, but I'm going to give you one more in addition to these. Let's look at this first function, negative 2x to the fifth plus 3x cubed minus 5x plus 1. What is the leading coefficient?
Negative
Negative
2.
Very good. Very nice. Very nice. Negative 2. All right, means negative 2. What is the degree of this function?
The fifth degree.
Yep. 5. Yep. How did you know that was the leading coefficient?
Because
How did
it's
you know
the
that?
highest. It always starts from highest to lowest.
All right, I'm going to challenge that theory in a few seconds. Let's go to the next one. F of x equals x cubed plus 6x squared minus x plus 7. What is the leading coefficient?
1.
1.
One
Negative
is
1.
correct.
Oh, okay. 1. Okay.
It's 1, right?
Yes.
Because 1 is understood to be in front of x cubed. What is the degree?
The
3.
third degree.
All right, very nice. What about this last one, funny looking one? F of x equals 14.
That's a constant. It's
Very good. What's the
We
leading
put 0.
coefficient?
Oh, I don't know. 1. 14.
14. Must be 14. All right. What's the degree? That's just the tricky part. What's the degree?
1.
Is it 14x to the 1 power?
No, ma'am. So the degree on 0?
Gotta be 0 then. Because 14, would you agree that 14 equals 14 times x to the 0? Would y'all agree?
yes.
Yeah. Because x to the 0 equals what? What does x to the 0 equal?
1.
Correct. So yes, they are the same. All right. Very good. Anybody know what type of, if you graphed it, what would that look like? That's a That's an out of the box question. You may not know. I just want to see if you just happen to know. If you graph that on a coordinate plane, how does it look?
It's gonna be a line.
What type of line?
Horizontal.
Very good. What type of line, Zoe?
Horizontal.
Horizontal. Yeah.
Very good. That's excellent. Horizontal line. If it was x equals a constant, what type of line would it be?
Parabola.
Linear.
No.
Uh-oh. If it was x equals 14,
Yeah,
what type of
vertical.
line is it? What did you say, Alicia or Nakiri? What did you say?
I say a vertical line.
Vertical line. Very good. Very good. Remember the last section we had x equals things. That represented the blank of blank. What fill in the blank.
Dr. Thomas, where
Yes.
will we be able to find this right here? Because I didn't see it in the folder to print off.
Really? Oh man. I didn't put it in
It stopped at 2.1.
I did.
You might have to try it on your
You
phone
probably
because
refresh it.
yeah,
Okay.
Oh,
yeah.
is it it's available?
Yes, ma'am.
Yes, ma'am. I printed it
Sometimes
out
You have
for
to
the team.
refresh.
okay.
Yeah.
Sometimes I forget to copy things over, but it's available. At least we just gotta figure out how to
Okay.
uh-huh. So go back to it. Uh every once in a while I forget to copy over things. So
Okay, I
but they
see
said
it.
it's there. It's there. All right. All right. So in the last section, we talked about the axis of symmetry and the line of symmetry. Remember, it was always x equals a constant. This, however, is y equals a constant. So if it's y equals a constant, it's a horizontal line. If it's x equals a constant, if you graphed it, it would be a vertical line. Let me give you, I'm going to make up a problem. Made up. What about f of x equals 5x minus 7x squared plus 3x to the fifth minus 9x to the sixth? What is the leading coefficient?
-9.
Correct. -9 would be the leading coefficient because what is the degree?
6.
6.
All right. Again, degree is highest exponent. All right, let's move on because so sometimes it's not going to be in perfect descending order. So be careful about that. Polynomial functions of the form f of x equals x to the n, where n is greater than or equal to 1, are called power functions. That's not really an important statement. You don't have to memorize that. It's just something that is true that I put in the notes. All right, this is where we need to get to. This is the nitty gritty of the section. First, if n is even, what am I referring to when we say n in this section?
Exponent.
Not exactly.
Non-negative integer.
I wanted something else. I want us to refer
The
n to in
degree.
this. The degree.
Okay.
All right. Let's just make it degree for this section. All right. So anytime I say n, I'm probably gonna refer to degree. So Kenna, you said exponent, right, Kenna?
I said
I think.
the non-negative integer.
Oh, non-negative integer. Okay.
Yeah.
So if y'all, somebody may have said exponent. I'm not sure. But if you said that, partially true. But degree is the highest exponent. So if n is even, the graphs resemble the graph of f of x equals x squared, believe it or not. So notice you're familiar with what's in black. F of x equals x squared. That's called the what function?
Quadratic.
Quadratic.
Quadratic. Very good. Or squaring function. Now notice what's in red. What's the degree of this function?
4.
4.
4. Is it an even number?
Yes, ma'am.
Yes, n is even. It's 4. So it will always resemble the x squared function. because the degree is even. Now, they're very similar, as you can see. The only thing that you probably notice that is a little different is the middle. Y'all see the x to the fourth is a little flatter in the center or in the middle, right? Y'all see that's the only really major difference between the two. All right, let's move over to the right. If n is odd, their graphs resemble the graph of f of x equals x cubed, which is known as what type of function?
Cubic.
Cubic function. All right, so we have what you're used to, the parent function here, f of x equals x cubed. You're used to that parent function from some sections ago. Now we are graphing higher order degree functions like x to the fifth power. Notice it resembles x to the third power. Very similar. 5 is an odd number, like 3. So the only difference, again, in the center or the middle part is a little flatter. All right. Any questions about that so far? That's crucial that we learn that today. All right. Let's look at this little chart here. So we have this first little chart on the right. Well, let's look at the left. On the left side, we're talking about when n is odd or when the degree is odd. It's going to resemble which function again if n was odd?
Cubic.
The cubic function.
Cubic. Very good. So if it was a positive leading coefficient, it's going to look like this, okay, in blue here. It's going to rise on the right and fall on the left if we have a positive leading coefficient. So even below it, we know that this is odd degree because it looks like a cubic function. It may not be x to the third, but it's going to be an odd degree. And notice again, it rises on the right, but falls on the left. Let's look at the right side over here. When it's a negative leading coefficient, what happens when it's a negative leading coefficient?
It rises
It's on the left.
It's rising on the left, right? On the left it's rising, and on the right it's falling. All right. So when you have a leading or negative leading coefficient, remember that's a reflection about the x-axis. If you can recall, some weeks ago, talked about reflections. All right. So we may not know, even this one at the bottom, we may not know what degree it is, but we do know the degree is what? Blank. The degree
negative.
is what?
Negative.
Well, the coefficient is negative. Good. And the degree is
Cubic.
what? Not necessarily.
Well,
The degree
it's odd.
is odd. We know it's odd. How do we know it's odd? Because notice on the left, it's rising. On the right, it's falling. So whenever it's an odd degree, one side is going to be going up and one side is going to be going down. Y'all get that? All right.
Yes, ma'am.
So write down what you have learned about the left hand and right hand behavior of an odd degree polynomial. So anyone want to volunteer? What did you just learn about the left hand and right hand behavior of an odd degree polynomial? Anything you learned? What did you learn?
When it's an odd degree, it's going to be on the left hand and it's going to be going up, and the bottom going to be going down.
All right, you said when it's a
Odd
odd
degree,
degree, the left hand
and it's
is
going to
going
be
to be,
going up.
no, not necessarily. What makes it go up or down depending on the side?
When it's an odd degree and it has a positive coefficient, it's going to rise from the right and
Okay.
then fall from the left. And
All right.
then
Okay.
when
When
it's
there
a
is,
negative leading coefficient, it's going to rise from the left and fall on the right.
okay, positive leading coefficient, it will rise on the which side?
The
The
right.
right
Right. Very good.
and fall on the left.
And fall on the left. All right. If it was a negative leading coefficient, it would be totally opposite. Y'all get that? Okay, do
Yes.
you get? Okay, good. Any questions about that one before we move on to even degree?
Can I take a picture of that real quick, Dr. Thomas?
Yes.
Okay, got it. Thank you.
All right.
Get on these.
All right. So we have a even degree. Which function will your graph look like if you had an even degree polynomial?
Quadratic.
Quadratic. All right. So we don't know, and this is what the dashed lines mean. We don't know what's going on in the center of these graphs, but we do know the end behavior. We know that if it's a positive leading coefficient, notice that it's rising on the left and rising on the right. And obviously, this looks more like a quadratic, a x squared one right here, because it's a parabola. All right. Now this one down below it, how do I still know that it's an even degree polynomial? Because notice, both ends are doing the same thing. If they were doing different things, I know it would be an odd degree polynomial. But since it's rising on the left and rising on the right, I know that this degree is even. Similarly, if you have a negative leading coefficient, but both ends are doing the same thing. Notice over here, the left side is falling, the right side is falling. So I know is an even degree, and I know is a negative leading coefficient. Again, both at this last little graph over here, both ends are falling. Falling on the left, falling on the right. That's how I know it's an even degree polynomial. All right. We again notice the middles are doing different things, but we do know the end behavior. All right. What can y'all tell me about the left hand and right hand behavior? Anybody want to volunteer to share something you learned about that just now?
If it's an even, positive leading, or if it's a positive leading coefficient, the both ends will rise, and if it's a negative leading coefficient, then both ends will fall.
All right. If it is a positive leading coefficient, both ends will rise. All right. If it is a negative leading coefficient, both ends will fall. Excellent. Any questions about that? Any questions? Okay. Here's, oh, Zoe probably wants her picture. Here you go, though. You got it, Zoe? All right. All right, I'm going to move on.
Yes, ma'am, I got it. Sorry.
Okay, okay. All right. Let's discuss. Applying the leading coefficient test, describe the right hand and left hand behavior of the graph of each function. Let's look at A. F of x equals negative x cubed plus 4x. All right. First question, what's the degree?
3.
3.
Very good. Someone other than Kenneth and Nakiria, what is the leading coefficient?
-1.
1. Oh,
-1. Very good. Next, someone other than Alicia, Kenneth, and Nakiria. Let's describe the right hand and left hand behavior. What's going on the right? Is it falling? What I'm asking is it falling on the right or is it rising on the right?
Falling?
Is it falling? Okay. So, okay. What is it doing on the left?
it's rising.
All right.
Rising.
All right. And I'm trying to put little dashes in the center because now with this one it's x cubed, so we kind of know what's going on with this one. All right. So we're gonna sketch it a little bit. But usually I'm probably gonna put little dashes in between because we may not know what's going on exactly in the center. All right, very good. B. Anybody? What is the degree?
4.
-4. I mean 4.
4. Degree is 4. Someone other than, I think Zoe said that. What is the leading coefficient?
1.
1. Very good.
1.
All right. Someone other than Zoe, Kenneth, and Alicia. What will this graph, which function will this function resemble? Other than Kenneth, Alicia, and Zoe.
Quadratic.
Quadratic. Very good. Other than the Kyria, Kenneth, Alicia, and Zoe. What's happening on the left? What's the left hand behavior? Left hand behavior.
It's falling on the left. Yeah, falling down.
It rise. It's a positive.
It's positive leading coefficient. Very good. Therefore, the left side is doing what, Alicia?
It's rising,
And the right side is doing what?
going down.
All right, here we go again. Here we go. We're not catching something. All right, again, what's the degree of B?
It's 4.
Is that an even or odd number?
It's an even number.
Even.
So it's gonna resemble one of these tables. If it's a positive leading coefficient,
gonna
notice
go up
both
on
ends
both sides.
will rise. Y'all get it? Or both ends will fall if it was a negative leading coefficient. But since our leading coefficient is positive, then we know that both ends
Gonna rise.
will rise. Y'all get it?
So we just pay
Yeah.
attention to the leading coefficient, not like
That's it.
Okay.
In the leading coefficient in the degree. Any questions? Other questions in that? All right. C. What is the degree of C?
5.
Very nice. What's the leading coefficient?
1.
1.
All right. This function will resemble what function?
Cubic.
Cubic. How do we know that?
Because it's
Because
odd.
the
Because
degree
5 is an
odd.
odd degree. Yes. It's going to resemble the cubic. Since it's a positive leading coefficient, what's going on the right hand side?
It's rising.
It's rising.
Very good. And on the left?
Falling.
It's falling.
It's falling.
Falling.
Nice. And I try to put little dashes because it's x to the fifth. So there's probably some real extra stuff going on in the middle that we don't know about just yet. We're going to get to it though. We're going to figure out what's going on in the middle when we find out the zeros of the polynomial functions. That tells us where it's crossing or touching the x-axis. All right. let's get to it. Find the zeros of the functions. So we're going to start with A again. This f of x equals negative x cubed plus 4x. How do we find zeros of a function?
Set it to 0.
It's 0, yeah.
0.
Yep. So we're going to set the function to 0. So I'm just going to say set negative x cubed plus 4x equals 0. And we have to solve. So what's the next step? What do you think the
You
next
got
step is?
factor.
Sure do. You have to factor. Other than Kenneth, anybody other than Kenneth can tell me what would you factor out?
X.
X.
A negative x.
Negative x. It starts with that negative. We're going to factor that negative x along with it.
Oh, no, no,
All right.
no.
All right. Negative x times what is negative x cubed plus 4x?
X squared plus 4.
It's squared minus 4.
X squared minus 4. All right. Because that negative times that negative give you positive. Any questions so far? Any questions so far? All right. What do you think is the next step?
Then you gotta get rid of the 4 or no.
I would have
Divide
just
the
squared
one.
and square rooted it, and then it would have been plus and minus.
Uh-huh. Very good. That's one way. What do you think I will probably make you do? It's the same, but I would rather you do what?
Plus 4 on both sides.
What's one of our favorite words in algebra? We got to do it again. We just did it. We got to do it again.
Distribute.
Factor. Factor.
Factor.
Yeah. Because this is a difference of two squares. All right. Just to ensure that you don't lose a 0, because some people will rush off and not put that plus minus, like Nakia said. She remembered, but everybody doesn't remember that. So we're going to factor that as negative x times what? Times what?
X
X
plus
X
plus
plus
2.
2,
X
x minus
minus
2.
2.
Correct. Now that we have completely factored, what should we do now?
Set each one of them to 0 and solve.
Very nice. Negative x equals 0. What word should we put there to really impress somebody that we know our
Or
math? Yes. Or x plus 2 equals 0, or x minus 2 equals 0. And Alicia said we're going to solve for x. So for the first one here, how do we solve for x?
divide everything by -1.
Okay. All right. Divide everything by -1. Very nice. So that gives us x equals 0. That's one of our zeros. 0. 0 just happens to be the 0. All right. And then next, you'll get what when we subtract 2?
X equals
X
-2.
Yep. -2 is a 0. And then when we add 2 for the last one, we get
X equals 2.
x equals 2. All right. So if I ask you what are the zeros, you would say the zeros are -2, 0, and 2. If I say what are the x-intercepts, I'm probably asking you to write it as a point. So how would I write these as a point?
-2, 0, 0, 0, 2, 0.
Very nice. All right. So I'm going to blow up. There's already a graph here of A right here. Y'all notice that it's rising on the left and falling to the right, like we said. All right. And what is this point?
The x-intercept.
All right,
Oh,
which one is it?
20. Negative 20.
It's probably negative 2, 0. What about this point?
0, 0.
Correct. And what about this point?
2, 0.
2, 0. Check, check, check. All right. Those are our x-intercepts. Any questions about A? Okay. Let's move on to B. All right. B is, let me change colors, maybe. X to the 4th minus 5x squared plus 4 equals 0. So that's what we're setting to 0. What's the next step?
You subtract 4 from each side.
Well, I only do that when it's x, the degree is 1.
Okay.
What happens when the degree is higher than 1? What did you say?
You can
Factor.
Factor, yes, okay. X to the 4th though, but what type of polynomial is this? What would you call this situation? That's
Trinomial.
called, it is a trinomial. Very good. Let's write that down. Trinomial. Y'all know how to factor trinomials. All right. What's the leading coefficient of this trinomial?
1.
1.
1. All right. If it was not 1, we would use a method called the AC method. Some of you all have heard of it. But since the leading coefficient is 1, I know it's a little easier, and I don't necessarily have to do the AC method. If you want to do the AC method, you can. All right? Because I know I can split up this x to the 4th. There's only one way to split x to the 4th up into 2. What times what?
x squared.
Yep. X squared times x squared will give you back the x to the 4th part. But I need to know something else to fill in the missing spaces. What else I'm trying to figure out?
Okay, you could do
B and C.
What
negative.
adds to, I mean, what multiplies to, is it what multiplies to 4 and adds to negative 5?
Yeah.
Correct.
So is it
Yes.
gonna be 1? I know the factor is gonna be 1 and 4. It's gonna be
Mhm.
negative 4 and 1.
Mhm.
Negative 1.
Negative 1.
Okay.
Negative 1 times negative
It's
4 is a positive 4, right?
Yeah.
But negative 1 plus a negative 4 will give you
it's
the
gonna be
middle
negative on
number.
both sides.
Yes. Negative 4, negative 1. What do y'all think I want you to do next?
Factor again.
Yes, I do want you to factor again. Because these are called what?
Difference of squares.
Difference of squares. So if it's a factorable situation, I would rather you factor it so you don't mess up and lose some zeros. Give me the factors of x squared minus 4.
X plus 2, x minus 2.
Correct. Someone other than Alicia, what are the factors of x squared minus 1?
X plus 1, X minus 1.
Correct. Someone other than Alicia, Nakiria, and Kenneth, what's the next step?
We're gonna set all these equal to 0.
True. X plus 2 equals 0, or x minus 2 equals 0, or x plus 1 equals 0, or x minus 1 equals 0. So the first one, we'll get negative 2, then positive 2, then negative 1, and then positive 1. If I said write it as x-intercepts, what do you think I'm asking for?
Write it as a point.
Yeah, that's right as a point. The x-intercepts are,
-2 and 0, 2 and
yep,
0,
Negative
yep,
1 and
and
0.
0, 1 and 0.
correct. All right, let's blow up the graph. The graph is on the right. I'm going to enlarge. Notice it's an even degree, so it's going to resemble the shape of a parabola, but obviously there's a lot more going on because we have a higher degree function than to the second power. Notice it was leading coefficient, so both ends are rising at the same time. All right, what point do you think this one is? Right there.
-2, 0.
Yep, probably. This one.
-1, 0.
This one.
1, 0.
And this one.
2, 0.
Correct. Any questions? All right, let's move on to C now. We're going to set x to the fifth minus x equals 0. Someone other than Kenneth, Alicia, and Nakiria, what would you do first?
Because you left me out, I think you going factor.
Factor.
Yes.
Yes. Well, how would you factor it though? That's the question.
You can pull the x out,
Very good.
and then when you pull the x out, yeah, x to the fourth minus 1. No, yeah,
Very
that's
nice.
minus 1.
Very nice. All right. Someone other than Alicia, Kenneth, Nakiria, and Zoe. What would you do next, or what would you think I want you to do next? Anybody other than Alicia, Kenneth, Nakiria, and Zoe. What would you do next? All right. Well, let me ask Alicia, Kenneth, Nakiria, or Zoe. What would you do next?
You're gonna factor again.
Factor
You're
again.
gonna factor again. Yep, because what is this called right here?
Difference of squares.
Yep, another difference of squares. So as long as you have a minus sign in the middle and you can find the square root of these terms here, it's called a difference of squares. And if you have a minus sign in the middle and you have perfect squares there, then you can break it down. Let's break it down. What are the factors?
X squared plus 1, x squared minus 1.
Very nice. Are we done factoring?
No,
Nope. All right, I'm writing x down. Can we factor x squared plus 1?
no,
No.
No, no. That's called a sum of squares. And a sum of squares is never factorable. All right, give me the factors for x squared minus 1.
x plus
X
1,
plus
x
1.
minus 1.
Very nice. We have finished factoring. What would you do now?
Set everything to 0.
Yes. X squared plus 1 equals 0, or x plus 1 equals 0, or x minus 1 equals 0. All right, so the first one is already done for us. It's already x equals something, 0 in this case. All right, this second one though, this one right here, what would you do first?
You'll subtract 1
Subtract
from
1
each
on
side.
both sides.
All right, x squared equals -1. Then what?
You have to get the square root
Square
of
root.
both
Yep.
sides.
And what's the problem here?
You have a negative inside.
Under the radical.
Yep, a negative number under the radical, which takes us into imaginary solution, and we haven't made it to that section yet. That's section 2.4. It's coming, but not now. So we're going to put an X through it. We only want the real zeros. They call them the real zeros, not the imaginary zeros just yet. The real zeros. We're in the real number system right now. All right. Oh, we got a question, I think. Zoe.
Okay, so like on Web of Science, we have problem. This gonna be does not exist, right?
No, we got zeros, right? You're only gonna put what you have. So we're
Oh,
working on it right
okay,
now.
okay,
You just won't include that one.
okay.
For example, we also have we got zero, that's one, and then we have what's the next one?
X
X equals
equal
one.
-1.
X equals -1, and also yes, x equals 1. So our zeros are -1, 0, and 1. If I ask you to write it as x-intercepts, you would write
-1, 0, 0, 0, 1, 0.
correct. All right, let's blow this up. We have a x to the fifth situation, degree 5. So it's going to resemble, and it does, very much so resembles the cubic function. All right. So what point is this, you think?
-1, 0,
Yep. What point you think that is?
0, 0,
And this one.
1, 0.
Yep. Those are your x-intercepts. Any questions about those so far? All right, very good. Very good. Next, real zeros of polynomial functions. It can be shown that for a polynomial function f of degree n, the following statements are true. Number one, the function f has at most n real zeros. At most n real zeros. All right. So, what does it mean? If I said to you, I have at most 60 pairs of shoes in my closet. What does that mean? I have at
Like
most.
an estimate.
No, not exactly. I have at most 60 pairs of shoes.
Greater
That's one of
than
those
what?
that's one of those math terms that is ambiguous, but we got to figure it out so we know what it's talking about. What do you say, Kenna?
I
What
was
are you
gonna
talking?
say, oh, great. Either I don't know. I want to say like
Mm-hmm.
greater than or equal to, but I could be
No.
wrong.
Any other guesses? Any other guesses before I just
So
Is
math.
it like when you like the lowest number, like you
not
telling
the
about
lowest,
the
not the
lowest?
lowest, the maximum number,
Oh,
I said that,
right?
Dr. Thomas.
Oh, sorry,
Yeah, I
Zoe.
think I was talking the same time somebody. I probably, but I
Yeah, I
said that.
think I thought I heard it, but I just thought I heard maximum. All right, so that means I have up to 60 pairs. So it could mean I have 0 pairs of shoes in my house, right? It could mean I have 1 pair, 2 pair, 3 pair, 4 pair, all the way up to 60. But 60 is the max. So the function f has at most n real zeros. N again is referring to what were we referring n to again?
Degree.
Degree. Okay. So here's what we're gonna go. We're gonna go back to the last page and look at what n is. It says it's gonna have at most n real zeros. So let's look at A. What's the degree of A?
3.
3. So we have three, at most three real zeros. So let's put it over here. That mean do that. Over here, at most, nope. Come on. At most 3. But now we we figure out the actual number of real zeros. Okay. We figured out how many did we really get? Y'all tell me. I don't want to go back to it.
2.
How many did for A?
3.
We actually found 3, yeah, for A. Right here. We did get 3. So it just happens to be the same thing. Normally it will. It's not always going to be that though. All right. Let's look at B. We're going to skip turning points because I haven't taught it yet. B. At most, how many are we supposed to have? What's N for B?
4.
4. At most 4 for B. At most 4. What was the actual number that we found? Number of real zeros.
4.
We actually found 4 for that one. A lot, but we found all 4 right here. All right. C. At most, how many do we supposed to have? The maximum number. Let me say that. What's the maximum number of zeros we could possibly have for C?
5.
5. All right. So it's gonna be at most 5. What were the actual number though? This one was a little different. What was the actual number of real zeros?
3.
3.
It was only 3. Okay. Notice that we ended up getting rid of the imaginary solutions. There were 2 imaginary over here, but we want to know how many real zeros. Okay. Real. All right, very good. Moving on. Next statement. Number 2. The graph of F has at most n minus 1 turning points. It's always going to be at most n minus 1 turning points. Turning points, also called relative minima or relative maxima, are points at which the graph changes from increasing to decreasing or from decreasing to increasing. All right. Finding the zeros of a polynomial function is one of the most important problems in algebra. All right, here we go. Let's go back to A. Let's figure out at most how many turning points we're supposed to have for A. N is what again for A?
Degree.
3 minus 1. What is 3 minus 1?
2.
2.
2.
2.
All right. So we're going to have for this one at most 2 turning points. That's the maximum number we can have. Let me show you what it means. Can y'all see my little mouse moving?
Mm-hmm.
Okay. So are we, if we trace this left side, we always go from left to right. Are we increasing or decreasing right here?
Decreasing.
Decreasing.
All right. So we started decreasing and then bam, it turned. So that's 1 turn right there. 1 turn. So we increasing and then bam, again, we turned.
Okay.
So how many turns were there actually? 2.
2.
2 turns. All right. So actual number of turning points, 2. All right. Let's look at B.
So, Ms. Thomas, will we always have like a graph for that, or you're showing us this case we don't have like a graph?
We always have a graph for it. I mean, you could always use Desmos, but you know, if I ask you how many, what's the maximum? I probably ask you what's the maximum number of turning points it could have. You know that answer because it's always n minus 1. All right. But if I give you the graph, then you can tell me what the actual number are. Okay, so it's two different situations. I could say what's the maximum number you could have, and you can tell me that because it's always n minus 1. All right, let's look at B. What's the degree of B?
4.
So what's the maximum number of turning points you can have?
3.
3.
3. All right, at most 3. Let's look at to see what's the actual number because we have the graph. So in this case, you definitely need to look at the graph to see. All right. So started off doing what? Decreasing or increasing?
Decreasing.
Decrease.
Decreasing. Bam. Turn 1. Going up. Bam. Turn 2. Going down. Bam. Turn 3. So how many actual number of turning points?
3.
3. All right. I want you to look back at C now and tell me what are the maximum number of turning points and what were the actual number of turning points? What is the maximum number you could possibly have and what was the actual number?
At most 4.
Maximum.
And actual is 2.
Oh, at most, what again?
At most 4.
Yes,
And actual is 2.
the actual is 2. Okay, you write that down. At most 4 and actual was just 2. All right. All right. Zoe, what's your question?
I think you were about to explain it, like how she
Yeah.
got it most 4.
All right. So what is the degree? The degree
It's
is
5.
5. So you always subtract 1 from that number. So at most, n minus 1 turning points. At most, n minus 1 turning points. N is 5 here. So it's at most 4 turning points. Get it? At most 4. All right. Let's look at on the left side. We started on the left. All right. Are we increasing or decreasing right here?
You're increasing.
Increasing. Then what happens?
You turn.
Turn. That's turn 1. Then what happens?
You turn again.
Turn
Then you go
again. It's
up
only 2 turns.
2 turns.
Only 2. You get that? Only 2 turns there. All right. So that one was the one that was slightly different. Just because you say that there is a maximum number doesn't mean it's going to be the same as the actual. Notice for real zeros, it had a maximum, at most it could be 5, but we only really ended up getting 3 real zeros because 2 actually were imaginary, so they weren't real. All right, turning points. You could have at most 4, but in actuality, when we looked at the graph, there were only 2 turning points. All right, let's look at this little graph here. Let's read this first. Okay, there is a strong interplay between graphical and algebraic approaches to this problem. Okay, what are we talking about? Let's look at this. Real zeros of polynomial functions. When f is a polynomial function and a is a real number, the following statements are equivalent. And I sort of talked about this, that all of these mean the same thing basically. X equals a. If x equals a is a zero of the function, oh well, x equals a is a zero of the function. I guess we can look back at one of these. Like x equals -1, for example. Let's say it was x equals -1. All right, let me change this. let's say x equals -1 is a 0. Isn't that also called a solution, you all, for number 2? Isn't that also called a solution? Then we solve the equation. Or 0 the solution. So number 2, statement number 2 was x equals a is a solution. All right. Number 3, x minus a is a factor. Wasn't it x minus -1, which equals x plus 1? All right. Let me show you what I mean. Then we start off as, y'all see it, x plus 1, which gave us x equals -1. All of this is related to each other. Also, number 4, a0 is an x-intercept. Didn't we change that to -1, 0 as the x-intercept? All of these are equivalent to each other. So if I ask you for the 0 or if I ask you for the solution, those are basically the same, and they are related to the factor and the x-intercept. All of them work together as one, really. All right. So that's all that box is saying. They are all interplaying with each other. Let's look at this. Find all real zeros of f of x equals -2x to the 4 plus 2x squared. Then determine the possible number of turning points of the graph of the function. Let's begin with finding zeros. All right. So I know you already set the function to 0. What did you do after that?
Factor.
Factor.
Yep.
Factor.
Did you take out -2x squared?
Yes.
Yes, ma'am.
Yes.
And
Did you get
then
x squared
Plus
minus
one.
I got -1.
minus?
Oh, yeah, -1. That's right. That's right.
All right. Then did you get -2x squared times x plus 1
X
times
minus
x
one.
minus 1?
Yes,
All
ma'am.
Yes,
right.
ma'am.
Mm-hmm.
Then you set each factor to 0. All right. For the first one, did you divide by 2 first?
Mhm.
Then do the square root of both sides. X equals 0. And then this one, you subtracted 1. X equals -1. And then you added 1. X equals +1. All right. Good job. So now let's plot our x-intercepts on the graph on the right. Give me one x-intercept.
0,
0,
0.
All right. What else?
negative.
-1, 0, and 1, 0.
And okay, very good. All right. Since this is, what degree is this polynomial?
To the
4.
4th degree.
To the 4th power. So it's going to resemble which function?
Even. Quadratic.
Quadratic. What's the leading coefficient?
Negative 2.
-2.
So what does that mean? What's going on the left side?
Both sides are going down.
Mhm.
Both sides are going down. Very good. So I don't know what's going on in the center just yet, but I do know is doing something like this. Y'all get that? We're gonna figure out what's going on in the center in a few seconds. All right. First, let me ask this question: do y'all get that they're gonna be falling on the left and right because the leading coefficient is negative, which means that there's a reflection across the x-axis. Any questions about that part? All right. One little more, one small piece that I have to teach before you go. All right. So, well, I want to do a couple examples from the book and then I'll let y'all go. All right. It says repeated zeros. A factor x minus a to the k power, where k is greater than 1, yields a repeated zero, x equals a of multiplicity k. That sure does sound like a lot of math terminology right there. All right. Number one, when K is odd. Now, what is K referring to? K is referring to the exponent of the factor. So where are our factors? Our factors are here. All right, here are our factors. Let me put a rectangle around our factors. All right. So we have this first one here. What do you think K is? That's a guess. It is the exponent. What do you think K is?
2.
2.
2.
Is that an even or odd number?
It's
Even.
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 Even. So it's saying that when K is even, the graph is going to touch the x-axis at that particular x-intercept. All right, it's going to touch. So it's going to touch at, or I like to say bounce there. Well, I say touch at 0, 0. All right, let's move on to the next factor. The next factor is x plus 1. What power do you think is outside of that parenthesis?
1.
Right here. 1. It's understood to be a 1 right here. Is that a odd K or an even K?
It's an even.
Odd.
Odd, right? K equals 1. So if K equals 1, then that's an odd number. 1 is an odd number. So therefore, the graph is going to cross the x-axis at x equals -1. All right. So for this one, it's going to cross at -1, 0. All right. Last one over here. This one right in here. What is K, you think?
1.
1 again. It's x minus 1 to the first power. All right. To the first power. So K equals 1. So it's going to also, since it's odd, cross the x-axis. Cross at 1, 0. That's going to help us with the graph. So let me blow it up a little bit. Over here at 1, 0, is it going to cross the x-axis or it's going to touch the x-axis?
Cross it.
So is it
Cross.
when it's crossed, it's going to go through it. That's what it means. It's going through the x-axis. All right, at 0, 0 though, so we got to kind of come back down because another one right here. At 0, 0, what's happening? Are we going to touch it or
It
cross it?
touches.
Gonna
Touch it.
touch. Yep. Just touch. It's not gonna go through. We're just gonna touch it, and then -1, 0. What happens? What are we doing at -1, 0?
Cross.
Cross.
Crossing. So
It
I'm gonna go
crosses.
back up. I can't go down. I gotta go back up and cross through -1, 0. So if you put this in Desmos, you'll see it looks pretty much sort of like this. Obviously, we did this by hand, so it's not as cute. But if you put it in Desmos, this function, that is, this function, then you'll see what the graph really looks like. And you'll see that that's correct. All right. We're going to do one last thing. Any questions about that? Repeat the K. So if the K is odd, we call that an odd multiplicity. And the graph crosses the x-axis at that intercept. If K is even, we call it an even multiplicity. And the graph touches or bounces right there. It doesn't go through the x-axis right there. All right. I want to show you all, I'm going to the book and stop. So what I'm going to do is ask you a series of questions for the next couple of minutes. All right. And I want you to direct message me the answer. Direct message me the answer. Don't send the answer to everyone. Find my name in the chat direct message. All right. Looking at A. All right. Got your hand on the trigger. Looking at A. It's not a race though. I want you to think about it. Looking at A. First question. Do we have an even degree or odd degree? Just put even or odd for A. All right. Even or for A. Even or odd. Again, direct message me. Okay. Because I want to know, I want to see if you really understand it. All right. I need more answers. Only 4 people sent me an answer. Okay. All right, Marvion, I think you sent it to everybody. You need to find my name in the chat. Let's see. Did you send the answer to everybody? Let's see.
I'm sorry.
Okay. You need to, don't send it to everyone. Just send it to me. All right. But Marion was right. Okay. All right. Me first ask this question. Second question. Is the leading coefficient positive or negative? So put that direct message me. Positive, negative. Okay. All right. So this telling me a lot. Only one person sent me. Okay. 2 people sent me the answer. Okay. All right. See, we're all over the place on it. Okay. A. Y'all look at the end behavior. Aren't both ends going in the same direction? Yes or no?
Yes.
Yes. Y'all see on the left side, y'all see it's falling, right? On the right side, it's falling too.
Mhm.
That's got to be like the quadratic. So it must be an even degree polynomial because both ends are doing the same thing at the same time. Now, because both are going down, that's a reflection, which means that the leading coefficient must have been negative. Negative leading coefficient, but even degree. So ask questions if you don't understand, because we're gonna go through B and C and D. All right, y'all think y'all got it now?
You
All
said
right.
so both ends go the same way on even.
A. So A, yeah. Both ends go in the same direction for even degree, right? Just like the quadratic. Both ends are going the same direction at the same time. All right, let's go to B. Direct message me. Is this a even degree or odd degree function? Okay, good, good, good. All right, everybody else, you just got to guess. Just guess. Just guess. If you hadn't responded, just guess. Okay. All right, let's look at B because we're not on the same page just yet. For B, notice one end is going one direction and the other end is going a different direction. That would be odd degree because they're going opposite directions. If they're going the same direction, it's a quadratic. Remember, a parabola is either going both up or both down. A cubic is either going on one side up and one side down. So B would be an odd degree function. All right, next question. Is the leading coefficient positive or negative? So all you have to do is put in positive or negative. Okay, good, good. All right, this is gonna be the last one because it's 5:15. All right, what's going on the right side, y'all? What's going on the right side?
It's going up or
It's
rising.
It's
rising.
going up. It's rising. On the left side, it's falling. So
Falling.
isn't it like positive leading coefficient x cubed? So it's a positive leading coefficient when the right side is going up and the left side is going down. If it was a negative leading coefficient, it would flip and the left side would be going up and the right side would be going down. Y'all